of you are able to see these slides, yes? Can you
Yes,
just,
sir.
okay, great, thank you. So let's see what is the problem. So Monica is concerning, so normally the start of a problem is very lengthy and not much information, but let's read it. Monica is considering the possibility of starting a company to produce small sailboats for the recreational market. Unlike the other mass production sailboats, however, these boats will be made specifically for the children between the age of 10 and 15. The boats will be on the highest quality and extremely stable, and the sail size will be reduced to prevent problem of capsizing. Okay, so just a story. What is the problem? Her basic decision is whether to build a large manufacturing facility, a small manufacturing facility, or no facility at all. With a favorable market, Monica can expect to make $90,000 from the large facility or $60,000 from the smaller one. If the market is unfavorable, however, Monica estimates that she would lose $30,000 with a large facility and $20,000 with a small facility. Okay, before going further, can we make a decision table here? Are the information enough to make a decision table? Yes or no? Not ready for quiz?
Yes, we have the data.
Okay, so all we need is to create a table, and in this table we have how many alternatives?
3.
3. Okay, so it will be large facilities, small facilities, or no facilities. Okay. Uh, what are the state of nature?
Favorable and
Favorable
unfavorable.
and unfavorable.
Exactly, favorable and unfavorable. Okay, so everything is favorable. How much is the benefit of a large plant?
90,000.
Exactly. So it will be $90,000. So you can go ahead and make a table for yourself as well if you want, then we can compare. Then if the market is unfavorable, how much is the cost of a large plant?
Negative 30,000.
60,000.
Yeah, it's very important. Some people may write 30,000 only. So it should be a negative mark, which shows the loss of money. Okay, what about a small plant? It will be 60,000. And how much is the loss if the market is unfavorable? Minus,
20,000.
that's right. Okay, and definitely here is 0 and 0. Okay, so the first step whenever a problem is given to you is to make a decision table. So it's clear now that what we're looking for, what is the structure of the problem, how many alternatives, and how many state of nature we have. Okay, so let's proceed with the problem. Because of the expense involved in developing the initial molds and acquiring the necessary equipment to produce fiberglass sailboats for young children, Monica has decided to conduct a pilot study to make sure that the market for that sailboat will be adequate. So it looks that if you make a decision, you have no option to go back. And because this is a very important decision, this is a strategic decision. So she has decided to perform a pilot study. Pilot study means something in a smaller size that you evaluate different situations and then go with a mass production. So she estimates that the pilot study will cost her $10,000. So it looks something like marketing search, but it's more technical. Furthermore, the pilot study can be either favorable or unfavorable. Monica estimates that the probability of a favorable market given a favorable pilot study is 0.8. And the probability of an unfavorable market given an unfavorable pilot study is 0.9. Okay, so before going further, what do you think about this problem? Are we making one decision or two decisions here?
Two decisions.
Two decisions, yes. The first decision is, if I go back, is either I need to make a large, small, or no plant. And the second decision here is either performing a pilot study or doing nothing. Do not perform a pilot study. And if we want to perform a pilot study, there are two options. The option number one is that the market is favorable. So based on the result of this pilot study, we notice that everything is fine. We should go ahead with establishing the, let's say, factories. And there is a chance that the market gets unfavorable. If the market gets unfavorable, so again, we have some results and it will let us know which option is the best. And as we can see here, there is 65% chance, okay, that the pilot study will be favorable, okay? So it looks that we have all the data required in order to make a decision. Okay, let's continue the problem. Of course, Monica could bypass the pilot study. It means that ignore it, do not perform pilot study, and simply make the decision as to whether to build a large plant, a small plant, or no plant. So we want to help Monica to make a decision. Without doing any testing in a pilot study, she estimates that the probability of favorable market is 0.6. So it means that if I go back, if I do not perform any pilot study, which means just using this table, there is 60% chance of favorable market and 40% chance of unfavorable. So when one of them is given, you can easily deduct one minus the first one and get the second probability, correct? So what is the question? What do you recommend? Compute the expected value of sample information. Okay. Do you want me to give you about 5 minutes to think about, and then we can continue? I think you have all information to do that. And just to review all possible steps that you can follow. Do you remember what are the steps to do this problem? Because we have two layers, it's a kind of sequential decision making. When it is sequential decision making, which technique we should use? When it is sequential decision making, it means that we need to make two decisions. Which technique we should use?
Decision tree.
That's right, decision tree. We should use decision tree. Okay, and if you want to make a decision tree, you need to follow 5 steps. Do you remember those 5 steps? Step number 1 is define the problem. That's right. Step number 2. Step number 2. It's just 2 days or one, maybe less than that. So you have forgotten?
Draw
the decision tree. Exactly. The structure of decision tree. That's right. Step number 3.
State of the nature.
Exactly. Define the probability of a state of natures. Step number 4. Calculate or estimate payoffs. Is it right?
Yes, with the alternatives.
Exactly. And finally, step number 5, which is calculating
Uh, EMV.
EMV.
expected monetary value. Yeah. So after you calculated the expected monetary value, you will select the highest or the lowest.
The bigger one, highest.
The highest one.
The
Thank
highest.
you. That's right. Okay, so uh, 2 minutes out of 5 minutes is gone. So please do those 5 steps to finish and answer this problem. If you want, I can go back to this slide as well. All you need from this slide is just a table, decision table. And probabilities are also given in this table. Okay, now the second slide. Anybody has found the answer? Okay, so let's answer this question. So what are the steps that we should follow again? The first step is,
Make nodes.
yeah, but the first step is to define the problem. What is the problem here that we should solve it? What is the decision that we should make?
From left to right, we start first with the pilot.
Okay, that's right. The problem here is not either to, make a small, large, or no plan. The problem here is, should we perform a pilot study or do not perform a pilot study? This is very important. So we should design the decision tree so that the main decision that we want to make is this decision, either perform a pilot study or not perform pilot study. Okay. So if I go to next slide, this is the structure of the problem. So as you can see, I have certain squares that is defining the decisions, and certain nodes, circles, that are deciding about, state of nature. Okay, so the problem here is either going from A to B, this arc, which is do not conduct a study, or from A to node 1, which is perform a study. please make sure muted. Thank you. So after you do that, definitely, if you want to perform a study from this one, from this arc, then you have two options: favorable market status coming out of your study, or the study shows that the market is unfavorable. And for each of two cases, still we have three alternatives to study. Okay, so step number one, defining the problem. Step number two, drawing the decision tree. So we draw this decision tree. Step number three, we should define the probabilities. Okay, so the first piece of problem is do not conduct a study. So when it says do not conduct a study, it means that we just should make a decision based on this table, decision table. Okay, so all I am going to do is to define 60% chance for favorable market and 40% chance for unfavorable market. And this is true for all of the large, small, and no planned decisions. Okay, so if the market is favorable, 60%. If the market is unfavorable, 40%. 60%, 40%. Definitely here, because both of them are zero, we don't need to calculate that again. Okay, so let's go for the second decision, second category of decisions. So when the market is favorable because of the study, so the study shows that, the pilot study shows that there is 65% chance that the market be favorable. So if the result of survey shows that the market is favorable, still we need to make a decision that which of these two options are the best, which of these three options. Okay, so here I should look at here at this part of the problem. Monica estimates that the probability of a favorable market given a favorable pilot study, which is a conditional probability, is 0.8. Okay, so 0.8, keep in your mind 0.8. So favorable study and given the favorable market is 0.8. Okay, so can I calculate the unfavorable market as well? Yes, if I do 1 minus 0.8, it will be 0.2. Okay, some of you may claim this is not given to us. You don't need. Okay, I just need to give you one part of that. If you have favorable, you can easily calculate favorable, unfavorable. Yeah, by deducting 1 minus 0.8, which is the probability of favorable market. Okay, the same for the rest. So 0.8, 0.2, the same as the small and large plant. Okay, we have also another state or another branch which is unfavorable. So unfavorable, favorable, and unfavorable, unfavorable. Okay, so two different states, two different conditional probabilities. So the second part, the probability of an unfavorable market given an unfavorable. So two unfavorable is 0.9. So unfavorable and unfavorable, how much is the probability? 0.9. Okay, I don't have the value of unfavorable, favorable. You can easily calculate that. So if you say 1 minus this value, which is 0.9, so how much will be the value? 0.1. Okay, so this is the probability of unfavorable, favorable. Okay, so this is 0.1. So you can copy it for the other option, which is large plant as well. Okay, so I did a step number one, which is identifying that what is the problem or what is the decision. So the decision is either perform a pilot study or not perform a pilot study. Step number two, what was step number two? Step number 2.
Decision, draw the tree.
Exactly, draw decision tree. Okay, and step number 3 was
Assign probabilities.
probabilities. Thank you. Assign probabilities to each of the state of natures that we did. Step number 4. What should we do in step number 4?
Payoff calculation.
Payoff.
Exactly, we should estimate payoffs. Payoffs, okay. So for payoffs, we need to review individual branches, okay? At the end of all of these branches, how much is our payoffs, okay? So let's start with the first one. So if the market is favorable, let me use a highlight. If the market is favorable and factor is small and we are not performing any study, so how much is the value? Market is small, we are not performing any study, and the market is favorable. How much we are earning? Clear for everyone? 60,000. So here I'm going to write 60,000. If the market is unfavorable and I am in a small facility, how much I should pay?
Minus 20.
That's right, minus 20,000. Minus 20,000. The same for the rest of them. So if the market is favorable and the facility is large, market is favorable and the facility is large, it'd be 90,000 and the other one's minus 30,000. So 90,000 and minus 30,000. And definitely here is 0. Okay, so I am done with this part, which is the case of do not perform any pilot study. When it comes to performing pilot study, I should be a little bit more careful, okay? So what should I do in this case? All the options that I have above, okay, are gonna help me to make a decision and define and estimate the payoffs for the rest of it. Okay, so if I perform a pilot study and it's small, how much is the payoff of a favorable market? So it will be very simple. If I do not perform any pilot study, how much I'm going to pay? How much I'm going to earn, sorry. 60,000, correct? 60,000. This is the money that will come to my pocket. And because I am performing a pilot study, how much is the cost of a pilot study?
10,000.
10,000, that's right. So I need to deduct 10,000 from whatever I am earning, okay? So how much is the value? 50,000, okay? This is correct for the same of the rest of them as well. So here will be, how much is the earning here? Minus 20, minus 20,000. Again, because I am performing pilot study, I should pay $10,000. So the result will be minus 30. Here I am paying 90. I am receiving 90, so it will be 90 minus $10,000 as the cost of this pilot study. So the result will be $80,000. And the rest of them, be careful about here. You're earning nothing. However, you need to pay $10,000 for the pilot study. So the result is minus $10,000. Okay. So when you are performing pilot study, all of these calculations are true for the second branch, which is an unfavorable survey results. Okay. Any questions so far? Is it clear for everyone?
Yes, sir.
This is the time, thank you. This is the time that you should ask your questions, any doubts, any problem, because, you know, next week, that's your time. You should solve the problem. Okay, so let's go with the step number 5. What should we do in step number 5?
Calculate EMV, expected monetary value.
Exactly. Calculate expected monetary value and decide the highest expected monetary value. Okay, so let me just make here a little bit cleaner. Okay. Then we can proceed from there. Okay, so the first thing that we should do is to calculate expected monetary value. Are the probability given? Yes, they are given. So all I need to do is to calculate expected monetary value. Anybody here has a calculator?
It will be 28,000 for upper.
Okay, so you have a calculator. Please help us here. So how
Small.
should I write here? It will be point. So for this node, what are the nodes? I should start from the nodes. Let's start from node number 2. So how much is the expected monetary value for node number 2? Can you tell me? So how to calculate it?
It will be 36,000, 60,000.
No, I mean the steps. So how should I write it?
60,000 and
60,000 into 0.6 minus 20,000
So-
into 0.4.
So probability is 60% to have a favorable market, and the payoff is 60. Okay. And plus 40% chance of unfavorable market, 40% chance of unfavorable market, multiply how much is the payoff? Minus 20. And the result is
28,000.
$28,000. And this is the number that belongs to node number 2. So we expect that under these circumstances, under these situations, we will earn $28,000 out of a small facility when we do not perform any pilot study. Okay, let's go with node number 3. So here I should say 60% of 90,000 and 40% from minus 30. So how much is this value?
42,000.
42,000.
54, I think.
Okay.
42,000.
42. So I have the values. I just want you to calculate. So 42. Okay. And when we do nothing, the value here is 0. And we don't need to write it here. We just have it here. Okay. So I have to compare between these three numbers: $28,000 all profit, $42,000 all profit, and 0. So which one is the maximum?
42,000.
$42,000. So when here on node B, which is in a square, we want to make a decision. What is the best decision here?
Construct large facilities.
Exactly, large facility. And how much is my earning?
42,000.
42,000. That's right. Okay, I should do calculations for the rest of nodes. So let's go to node number 4. So it will be 80% or 0.8 multiply 50 plus 0.2 multiply minus 30,000. How much is that?
34.
$34,000. Okay, great. And then the next one for node number 5, 80% of 80.
56.
How much?
56,000.
56,000. 56,000.
Perfect. Okay, here I need to make a decision. I am on another score and I need to make a decision. So I should select between $34,000, $56,000, and minus $10,000. Which one will be selected?
56,000.
56, perfect. So here will be another large plant and my earning will be $56,000. Good. Okay, and the other branch here, what do I have?
22,000.
Calculations shows 42,000. Okay,
So 22,000.
22.
Yes.
Yes, sir.
Okay,
Negative 22.
negative. Oh yeah, that should be negative number.
Yes, sir. Negative 22.
Thank you. So be careful. You see, just a minus mark will change everything. And then for the next node,
Minus 28.
minus 28. Okay, and the last one is clear, minus 10,000. So which one is the best value?
Minus
10,000.
So this is the best value, yeah? This is the maximum number among these numbers. So here, the best option for this decision, decision D, is do nothing, okay? And the cost of do nothing is minus $10,000, okay? Okay. So we are done with this layer of decisions. All of this part is done. Now we should move forward to the next stage. What is next stage? I see node 1 here that I should still do some calculations, which is calculating um, expected monetary value based on a state of natures. So what are two different branches here? Number one is favorable study, which has a 65% chance. So if I want to calculate expected monetary value for node number 1, which is this node, okay, this node. So it will be 65% chance of a favorable market multiply. How much is the payoff of that market?
56,000.
56,000.
56. That's right. Plus, how much is the probability of unfavorable market?
0.35 into minus 10,000.
35 multiply $10,000 minus 10,000. So can you let me how much is this value? How much?
32,000.
30,000?
32.
32,900.
32.
92. 092. Okay. Correct?
900.
Sir,
900.
900. 32,900.
Okay, 32,900. Okay, not this number. Okay, so the last thing I need to do is make a decision. This is my most important decision here that I should make, and I have prepared everything to make a decision. Okay, should I perform a survey or I should not perform a survey or pilot study?
No,
Do
sir.
not conduct
No survey.
study. No survey.
Okay, so as you can see, if I perform a study, I will earn 30 to almost 33,000. If I do not perform a study, I will end up with 42. Okay, so first of all, do not perform pilot study. Second point, what is the best option in terms of size of facility?
We should construct large plant.
Large plant, that's right. So if I go one by one, and if I want to cut the branches, So starting from here, I should cut this branch and cut this branch, correct? And here I should cut this branch and this branch. Here I should cut this branch and this branch. And then finally here I should cut this branch. So the best option here, as you can see, is this branch. So only one branch is remaining here, which end up to do not conduct any study and go for a large facility. Okay, clear for everyone?
Yes, sir. I just want to ask one thing.
Sure.
So here we are making 4 decisions, right? Out of 4 decisions, 1 decision we have to select.
Exactly. We have 4 decisions. So in the first layer, we are making 3 decisions, and finally, we are making the major decision at last.
Thank you.
Perfect. So let's see if we have finished the problem. What is the problem is asking? What do you recommend? Yes, go with a large plant and do not perform pilot study. And then compute the expected value of sample information. What should we do here?
Expected value with no sample information minus expected value with sample information.
Okay. Any other comments?
Expected value with sample information plus cost
Okay.
minus expected value would be the best decision without sample information.
Okay, perfect. So if we go further, so as you can see, all the calculations are here. You can go ahead. Expected value of sample information is equal to $32,900, which is the best value here. Okay, if you perform a sample information, the best thing that you can earn is this much money. So this money plus the cost of survey minus the best expected monetary value, which is $42,000. So it's only $900. Can you interpret what does $900 mean?
Yes, sir. The value of extra information would be 900. So it's here, it's 10,000. So we are not going to spend that much.
That's right. Thank you very much. You understand this problem perfectly. So because the cost of this pilot study, which is $10,000, much more than 900, which is our maximum money that we are willing to pay. So in this case, we are not going to go with the expected value. We are not going to go with the pilot study. Perfect. Any questions? Any comments? So the problems will be very similar to this one. So the problems that we'll be asking your quiz. However, I'm not going to ask you to do all the steps, maybe just some of them. Okay. So if you don't have any further questions, we can go with another problem, which is a minimization problem. No questions? Okay.
Sir, there is one more thing.
Sure.
Do we need to calculate the efficiency of sample information in this?
The efficiency, you can go ahead. Do you want to calculate that?
Yes, sir.
But you know, we don't have the expected value of perfect information here. Okay. So we first need to calculate that, and based on that value, we can go ahead with this one. So it needs to go back and calculate the expected value with perfect information. And yeah, if you do calculate those steps, definitely you can calculate. And what is the formula with efficiency? You remember?
The EV, expected value sample information divided by with the perfect information.
That's right. Multiply 100. So we have this part, but we don't have expected value with perfect information. Can we calculate it? Yes, we can. Definitely, if I go back here, I can start from here. I can calculate all the numbers. Definitely, it's possible. Just to save the time, I don't want to go to there. But yes, you can calculate that number and just put in this equation and evaluate the numbers. Perfect. So let's start another problem, and this is the last problem we want to solve. First, let's give it a read. Beverly Hills has decided to lease a hybrid car to save on gasoline expenses and to do her parts to help keep the environment clean. The car she selected is available from only one dealer in the local area, but that dealer has several leasing options to accommodate a variety of driving patterns. So the problem is to select one car to purchase, but I have already three different alternatives. What are these three alternatives? All the leases are for 3 years and require no money at the time of signing the lease. The first option has a monthly cost of $330, a total mileage allowance of 36,000 miles, which means that in each year, if you divide it by 3 years, so 36,000 divided by 3 years, which means that in average, each year, Beverly can drive 12,000 miles. And a cost of $0.35 per mile for any mileage over 36, okay? So the following table summarizes each of these three lease options. Okay, what do we see here? Option number 1 for leasing is going with a monthly cost of 330, maximum after 3 years there's 36,000 miles, which means 12,000 per year. And if, for example, Beverly goes 36,000 and 1 kilometer, so for that 1 kilometer, she should pay $0.35. If she goes 36 and 2 kilometers, so she has to pay 2 multiply 0.35 and up to the end. So as you can see, we have two types of cost, a fixed cost and a variable cost. Option number 2, option number 3, all of them are given here. As you can see here, if she goes with higher mileage, higher allowance for mileage, she has to pay more monthly cost and less for excess miles, okay? Because everything is already covered in previous costs. Okay, so let's review the problem. So how many alternatives you see here?
3.
We have 3 alternatives, that's right. And how many state of natures you see here?
3.
3. So can you open up what are those 3 those 3 state of natures?
Monthly cost, marriage allowance, and cost for accessory.
No, a state of nature. Because 3 is the correct answer, but what do you mean by 3? How did you get to 3?
Mileage allowance.
Mileage allowances. That could be a right answer. Thank you. Okay. So I think we know what is the problem. Okay, another question. Is it a maximization problem or minimization problem?
Minimization, because cost, it's related to cost.
Okay, this is a minimization problem because this is related to minimizing the total cost of leasing. That's right. Okay, let's continue the problem. Beverly has estimated that during the 3 years of the lease, there is a 40% chance that she will drive an average of 12,000 miles per year. 30% chance that she will drive an average of 15,000 miles per year, and 30% chance that she will drive 18,000 miles per year. In evaluating these options, Beverly would like to keep her cost as low as possible. So this is a minimization problem. Okay, so we should answer a set of questions. Part A, develop a payoff or cost table for this situation. Okay, how should I do that? I should create a decision tree, yeah? That's the first thing. As you can see, I should create a payoff table or decision tree, whatever. Decision table, sorry, decision table for this situation. So what should I do? Any idea? Do you want to think more? Anybody else in this class want to contribute? I see there are some good students in the class and some silent students. Okay, first of all, I have three options, yeah? Option 1, option 2, and option 3. So 3 alternatives. Now I have to investigate a state of nature. What are states of nature? Maybe this slide helps. So you have probabilities for something. Those somethings could be a state of nature.
Mileage.
Mileage, that's right. So we have the probability of 40% chance for average of 12,000 miles. Okay, so what does it mean? It means that this is one of the state of natures. So one of the state of natures is that she drives in average of 12,000 miles. Another state of nature is that she drives an average of 15,000 miles. Another state of nature is that she drives 18,000 of miles. So three different state of nature. So it will be something like this: 12,000 miles per year, which is in 3 years, it will be 36. Is it correct? And then I have 15,000 miles. So in 3 years, it will be 45,000. And finally, what do I have? 18,000. Okay, 18,000 miles, which is my last state of nature. Okay, now I have to calculate the costs inside each of these items. So if I go with option number 1, I have a fixed cost plus a variable cost. Okay, so if I go with the first state of nature, how much is the cost? Fixed cost.
330.
So 330
Plus
multiply
40,000.
how many months? How many months is available in 3 years?
36.
36. Okay, that's correct. Multiply the number of months. Okay, so in 3 years we have 36 months. So 36 multiply the fixed cost for each month. Plus, how much is the variable cost? Under 12,000 miles, does she need to pay extra cost for
No.
because everything is under control, yeah? Because if she's gonna drive 12,000 miles per year, it means that she is under mileage allowance. So she does not need to pay this variable cost, correct? So let's go with the, so here, what should I write? Can somebody calculate 36 multiply 330?
1188000.
118, so 118,000, is it correct?
880.
Okay, I can't understand what you're talking. Let me.
11,880.
Okay, 11,850.
80.
80.
80. Okay, correct.
Yes, sir.
Thank you. So let's go for the next option. The next option is that still she goes with option number 1, but she needs to calculate uh, the cost for 15,000. So it will be the same. So we will have a monthly cost, fixed cost of fixed cost actually, plus a variable cost. How much is the variable cost if she drives $15,000 miles in average? So it will be like, how much is going extra?
Nothing.
So $15,000 minus $12,000. Why I am saying dollars? 15,000 miles minus 12,000 miles, which will be 30,000 miles. Okay, or sorry, 3,000 miles. So this 3,000 miles, which is coming from 15,000 miles minus 12,000 miles, okay, is reflected here. Minus for how many years? 3 years, correct?
3 years.
That's right. Multiply. How much is the extra cost for each mile? 0.35. So can somebody calculate 9,000 multiply 0.35 plus the fixed cost?
3150.
Okay,
Sorry, just a minute.
9,000 multiply 0.35.
15,030.
15,030.
15,000.
30.
Is it right?
030. Yeah.
Okay, so I will write this number here. So this cost will be this number. And now I want to calculate this part. So what should I write here? Here instead
Sorry,
of,
sir. Sorry, sir. The number here we need to take 330 times 36 plus 9,000 times the extra mile, right? So it should be 326,880 because we plasma.
I couldn't hear you very well, to be honest. Which part are you?
All
Are you
right.
talking
So
about variable cost?
I mean the 15,000 for
Okay.
yeah, the 15,000 here. So this number is for only 3,000 times 3 times 0.35, or we need to plus with the fixed cost
Yes. Yes.
330.
I think your
So
colleague already added that as well,
not yet.
because it's 11. So the fixed part of that is 11,880, and the variable part of that is 3,150. Is it right, everyone? So if we add them together, it will be this number. So there is a variable cost and fixed cost. Fixed cost, still we need to pay for fixed cost of 36 months and a variable cost of 3,150. Okay. And then we have, is it clear now?
So sorry, I am getting confused in the first step.
Okay.
So in how we are calculating the total cost for like 11,880, 11,880, Because we are multiplying 36. It's for what is 36 here?
3 years.
Uh, okay, got it. Thank you.
Okay. Any other questions? You're spending a lot of time for this stage, but that's fine. Then we should go for this option. How to calculate this part? So it will be a fixed cost, which is $330 multiply 36 months plus how much is the maximum mileage? 18,000. Okay, 18,000 minus 12,000, which is the maximum allowance for this leasing option, multiply 3 years, correct? Multiply how much is the cost of excessive mileage?
0.15.
Uh,
Sorry, 0.35. Yeah.
135. Okay, so can somebody calculate that? I know already this part is 11,880, but for the second part, so it will be 6,000 multiplied 3 multiplied this number.
13,980.
It cannot be 14,000.
18,000.
18,180.
180.
Thank you. So I'm gonna write 18,180. Correct. And I do the same calculations for the rest of option. Can somebody calculate the rest of them very fast? For this option, it will be 380 multiply 36 months. How much is that?
13,680.
13,680. And then for the middle one here, we should have the same thing. Nothing is changing. Is it correct? Because I'm not going to pay any excessive cost. 13,680. And then what about here? I should pay a fixed cost, which is this one, plus a variable cost of excessive mileage. So the variable cost of excessive mileage is here I am going 18,000 miles minus what is the maximum allowance for second leasing option? 15,000, which is $3,000 in total, correct? Multiply 3 years, multiply how much is the cost of excessive mileage?
0.25.
Exactly. So how much will be the value of just the variable cost?
$15,930.
No, it will be 2,250. This should be added to the previous one. So how much is the total?
Now it will be 15,950.
15,000.
930.
930. Thank you. The same for the last one. We have a variable cost here. Fixed cost, which is 430. This should be multiplied to 36. So how much will be that value?
15,480.
15,480.
480.
Okay. This will be repeated for all of them because we are not going above this for any other options. All of the alternatives will be less than this one. Okay. Okay, our table is ready, finally. So what should we do as the next step? The next step is to define, to answer the questions here. We have the best case and the worst case. How much is the best cost in this row? The lowest or the highest?
Highest.
The
18
lowest.
or
Yes, I should go with the first leasing option. And what about here?
13,680.
That's right. And here is 15,480. Great. And what should I write here at the worst case for the first leasing option?
18,180.
80. And here is 15. Sorry for my bad handwriting. I'm writing with a mouse. And finally, 15,480. Okay. So let's answer the questions. Number one. So we did the first part, which is actually developing a payoff or cost table. Part B, what decision would Beverly make if she were optimistic? So if she is optimistic, what should she do?
See the minimum cost.
The minimum cost. So what is the minimum cost here?
11,880.
The lowest on the best situation. So the lowest in this column. Which one is the lowest on the best cost? This one. So she should go with leasing option 1 if she wants to be optimistic. Correct? Everybody agrees?
Yes, sir.
Okay, we can directly look at the table and see that this is the minimum cost as well. So that's another way. Okay, we did with this option as well. Next option. What decision would Beverly make if she were pessimistic? So if she's pessimistic, let's
Testing the
use.
maximum output
The
to
last
limit.
15 for it.
So if she is
15.
pessimistic, we will look at the worst case and then we want to choose the minimum cost in the worst case. So if you look at the worst case, which one is the minimum? In
Third
this,
one.
so this
15
option,
480.
15,480 is the minimum. So if she's pessimistic, she will go with leasing option 3. So she's gonna try to minimize the worst case. Okay. Okay, we're done with this one as well. What decisions would Beverly make if she wants to minimize her expected cost or monetary value? So here we need to apply the probabilities because the problem is going to be a kind of decision making under
Uncertainty.
no, it was under uncertainty. No, it will be under risk. Okay, so when it comes to decision making under risk, we need to know the probabilities. How much is the probability of going with 12,000 miles per year? 40%, yeah, as given here. You see, 40% chance that she drives for 12,000. Okay, and then 30% chance here that she drives 15,000 per mile, and 30% chance for the last state of nature. Okay, so we need to minimize expected monetary value. What should I do?
Calculate the weighted value.
Exactly, which I should calculate expected monetary value for each of these 3 states, which each of them. So if I write here expected monetary value for the first option. So can somebody calculate how much is 40.4 or 40% multiply this number plus 30% multiply this number plus 0.3 multiply this number. How much is the value? And I appreciate if a second person goes with a second leasing option and another person goes with the third one, just to save the time.
14,750.
Okay, just a moment. Here we are trying to minimize the cost, correct? So here we should minimize the expected monetary value or maximize it. Minimize. That's one option. Or we can go with expected opportunity loss table. So we are going to create another table which is called expected opportunity loss. After you created that table, expected opportunity loss, everything will be in terms of losing money. Okay. So over there, I'm going to look at the maximum number in each row. So maximum number in this row is the minimum one. The best value is the minimum. Here the best value is this one, and here the best value is this one. Okay, so I'm going to deduct each option from the best value from that column. So I'm going to look like this. So just go back. I have two options: calculate expected monetary value or calculate expected opportunity loss. If I go with expected monetary value, all I needed to do is to calculate this column and select the minimum of that. Yeah, the minimum expected monetary value, because everything will be in terms of cost. Or alternatively, I can translate everything in terms of opportunity loss. So I'm going to create a new table. In the new table, all you want to do is to deduct the best value from the value for each of them. So a new table would look like this. So the best value is 11.880 minus the individual values in this column. So this number minus this number, this number minus this number, this number minus this number. And I will create a new table. The same for this column. After created that table, I need to multiply these probabilities, and then which one will be selected, the minimum or the maximum? The options that has the maximum value. Expected opportunity loss has the maximum value. Okay. So can we continue with this one? How much was the value of the first one? This one, expected monetary value for the first option. You just told me, you just forgot that?
14,750.
Okay, next option. Can another group calculate the third one?
It's
14,
15,480.
So for
Third
the
one.
second option, okay, second option first, how much is that? Let's go with third option. How much was that?
15,480.
15,480. Okay, 18. Okay, and the last one, the second option,
14,355.
355. Okay, so which option provides you the minimum cost?
Second option.
Second option provides you the minimum cost. Okay, so in this case, you need to go with the second option if you want to minimize expected monetary value. Okay, and calculate the expected value of perfect information for this problem. How much is that? So what is the best value in this column?
15,480.
Okay, how much is the best value in the second column?
15.
What is the best value in this column?
15.
15 for it.
Okay, can somebody multiply the probabilities to each of the best values for each column? And then I will write it here. And this will be expected value with expected value of perfect information. So 40% multiply the best value in this column plus 30% multiply the best value in this column plus 30% the best value of this column. How much is that?
13,500.
13,500. Okay. Okay. So as we can see, this is the minimum possible cost. Even this is better than any other alternative. This is called expected value of perfect information. Okay. And I think that's all for today. We answered all of the questions. Okay. Any questions before we wrap up today's session? If there,
So I have
okay.
a question for the quiz. That the quiz we will choose one solution, one kind of problem, or we will choose two solution for two problem like decision trees and also minimization.
Okay. So all I am going to do is to make it simple for you.